Hey there, Mr. Sutton here, bringing you the Algebra 2 3-1 Part 3 homework solutions on solving quadratic equations. In this one, we solve with some a little bit advanced kind of factoring techniques, including the AC method, and there's a word problem thrown in for good measure. On this problem, I'm trying to find the zero of this function right here. That basically just means I have to set this equal to 0 and then solve for x. Okay, well, let me try factoring this before I do anything else here. Now, since I don't have an a value of 1, since I've got an a of 4 here, this is not going to be necessarily an easy sort of what multiplies to 9 adds up to negative 12 kind of situation. I might have to use the AC method on this, but let me first try one of my square root shortcuts. Since 4x squared and 9 are both square roots, this might be one of those we have a negative here, so this might be like an a minus b parentheses squared kind of situation. Let's try it out and see if we actually do have this a squared minus 2ab plus b squared sort of shortcut. Alright, so if we do, then I just need to square root the first and last things and stick them in a parentheses. Square root of 4x squared would be 2x. Square root of 9 would be 3, and again the middle term's negative, so I would have a negative whatever that square root was, negative 3. Now let me just double check and make sure this actually works to get this 2ab here. If I multiply 2x and negative 3 together and double it, do I get negative 12x? Well, 2x times negative 3 is negative 6, twice that is negative 12x, so yeah, that works. Now I just have to set 2x minus 3 equal to 0 and solve it. So if I do that, I can add 3 to the other side and then just divide by 2 to get x equals 3 halves. For this problem, I'm trying to zero out this function. Let me just start by then setting it equal to 0 and solving for x. So I'm going to try to factor this on the left side and use my zero product property. Before I resort to guess and check or the AC method though, because I noticed that this is not 1x squared, a value that's not 1 here, let me first try taking out or dividing by a common factor. So it looks like all my coefficients are divisible by 2. We have a common factor of 2. So if I divide by 2, that leaves me with x squared minus 1x minus 6 equals 0. And now that I've got 1x squared, I think I can just try my my normal sort of factoring, where I look for numbers that multiply to the last number and add up to that middle coefficient. So are there numbers that multiply to negative 6 and add up to negative 1? Well, 1 and 6 won't work. 2 and 3 works if I have positive 2 and negative 3. So let me rewrite this then as x plus 2, x minus 3 equals 0. And now I can just zero each of these out to get my x. So for the first parentheses, we have x equals negative 2. And then for the next one, we've got x equals 3. On this problem, I'm going to try to solve this equation by factoring. First, let me start by zeroing this out by subtracting that 4 over to the left side. And now I've got to actually try to factor this. So since I don't have an a value of 1, I've got this 3 out in front. And I'm noticing that I can't just divide 3 away as a common factor. Let me try the AC method here. So my AC value, 3 times negative 4, is negative 12. And now I'm going to be looking for factors of negative 12 that add up to 11. Well, 1 and 12 works pretty quickly. If I have a negative 1 and positive 12, that adds up to positive 11. So what I'm going to do with that is split this 11p up into negative 1p plus 12p. And now that I've rewritten this with 4 terms, I can factor this by grouping. So let me take a common factor out of my first 2 terms. Looks like the only thing I can take out there is p. That leaves me with 3p minus 1. For the last 2 terms, 12p and negative 4, I think I can take a 4 out of both of those, leaving me with 3p and minus 1. Since I ended up with the same thing in both parentheses, 3p minus 1, I can take that out as a common factor. And then p plus 4 is my leftover parentheses to put next to that. Alright, so I've got this totally factored. Now I just have to set each factor equal to 0 and solve it. So if 3p minus 1 equals 0, that means I can add 1 and write 3p equals 1. And then just dividing by 3, we get p equals 1/3. And then for p plus 4, negative 4 plus 4 is 0, so I get that p-value pretty quickly there. If we're trying to find the 0 of this function, we're going to start by first setting this thing equal to 0. There we go. Now we just have to solve it for x. Well, this is not an a value of 1, so if I'm going to try to solve this by factoring, I'm going to have to be a little more clever than just figuring out things that multiply to 6 and add up to negative 19. Let me try the AC method on this. There's no GCF that I can take out, so let's go to AC. So 8 times 6 gives me an AC of 48. And now I'm going to look for factors of 48 that add up to negative 19. Well, let me think. 1 and 48 doesn't work. Then there's 2 and 24. No good. 3 times 16. That might work if I have negative 3 and negative 16. So let me split this negative 19x up into a minus 3x and a minus 16x. And now that I have 4 terms that I've rewritten this thing with, I'm just going to factor this by grouping. So for my first two, I can take an x out of those. That leaves me with 8x minus 3. And then for the next ones, I can take a negative 2 out of those, leaving me with an 8x and a minus 3 as well. So then 8x minus 3 comes out of everything. That's a common factor. And then x minus 2 is the other factor. All right, so setting each of these equal to 0 and solving, if 8x minus 3 equals 0, that means 8x equals 3. And then dividing by 8, we get x equals 3 over 8. And then 2 minus 2 is 0, so that's my other answer. For this problem, we have an athletic store charging $120 for a pair of basketball shoes and selling $200 per month. And then for each $2 increase, they sell 2 fewer pairs of shoes. Based on that, we want to know how much they should charge to maximize their monthly revenue. And then what is that maximum revenue? All right, so the thing that we are controlling here that we can change is how many of these $2 increases we execute. So I'm going to let x represent the number of price increases. So my revenue, which I'm trying to maximize, is basically price times number of items sold. I'm going to express each of those in terms of this x. So for the price, since we're starting at $120, I can express the price as $120 minus 2 times x, or actually plus 2x, because I'm actually increasing by $2. So if I figure out how many increases I have and multiply that by 2 and add that to 120, this is giving me the new price. Now how about the number of customers based off that price increase? Well, we started with 200 shoes per month being sold, or pairs per month, and we lose 2, they said, 2 fewer for every time we increase that price. So we could write 200 minus 2x. And now let me just set this equal to 0 and get my x-intercepts. If I'm going to try to maximize this, since it's intercept form, my strategy is going to be to get the x-intercepts and average those to get the vertex. And that'll give me my max. So setting this equal to 0 and zeroing each of these out, we have 120 equals negative 2x for this first parentheses. So x equals negative 60 out of that. And then over here, we have 200 equals 2x, so x equals 100. So these are the number of price increases, or I guess this would be a decrease in this case, where it's going to zero out my revenue, either because I'm charging $0 for the shoes, or because I just run out of customers who don't want to buy my overpriced shoes. So to get the vertex, let me average these x values together. So negative 60 plus 100 over 2. That's going to give me 40 over 2, which is 20. So 20 is the number of $2 increases that will maximize my price. What is that new price? Well, that's going to be 120 plus 2 times the 20 that I just found here. So 120 plus 40 gives me $160 for a pair of basketball shoes. And then for the revenue generated from that, we just plug 20 into the general f of x expression that I wrote here. So let me calculate that on Desmos. So plugging that all in, let me actually just write f of x as a function. I think this will be cleaner. 200 minus 2x, and then I'm just going to plug 20 into the function I just wrote there. There we go, 25,600. So that is how much money we're getting in the best case scenario.